Hello students, now let us look at the next topic called as domain name system, or it is also called as your DNS protocol. So DNS protocol is basically an application layer protocol. It uses a port number called 53 and it basically uses both the TCP and UDP. So we will see that stuff in the later slides. But first, first we have to understand why we need to use this domain name system protocol. For example, if I ask someone to tell what is the IP address of Flipkart.com, what is the IP address of Amazon.com, you will not be able to remember the IP address. We know IP address is a 32-bit IP address where we will be writing it as a 88 bits. Okay, so it is difficult for the humans to remember the IP address. So this IP address will be converted to some form of naming. Okay, so that conversion only will be basically taken care of by this domain name system. For example, if I say Amazon is having an IP address like 200.192.192.192, that is for Amazon one means you can remember. Likewise, we know we are accessing n number of websites. For n number of websites, there are n number of IP addresses which cannot be remembered by us. So that is the main reason. By using these domain name system or these domain name servers, we will be able to do the mapping. So for 200.192.192.192 is mapped to Amazon.com. Likewise, 200.192 different addresses. So it might be mapped to another website. So that is the main idea of going for this domain name system. So given this slide, so here we are seeing an example of using the domain name server. Let us say they have shown a simple diagram. Here they have shown how conversion of an SMTP server is done here. We know what do you mean by SMTP. So SMTP stands for your simple mail transfer protocol. So for sending and receiving mails, we'll be using this SMTP protocol. For example, a user wants to send a mail to a person at wonderful.com. So we know in internet, we need IP addresses. Only with the help of IP addresses, we'll be able to communicate. So first, this is the application layer. So this SMTP client wants to identify or wants to know what is the IP address of this wonderful.com server. So what it will do, this is a sending PC. So this SMTP client will be sending a request to the DNS client asking to do the resolution. Resolution means to find out what is the IP address of wonderful.com. So if this DNS client is having the data or the IP address, it will be sending that IP address to the client. So let us take for example, in our case, this client is not having the IP address. So what it will do, it will then contact the remote DNS server, or it might be a remote DNS machine where it will go and ask. So I need to identify what is the IP address of wonderful.com. So if that DNS server is having, it will be giving the IP address. So once it gets the IP address, this it will be forwarded to our DNS client. Then our DNS client will be sending to SMTP client, and this SMTP client in turn will be sending the mail to this particular IP address. So how this DNS client is doing the conversion, like it will be sending the MX record, mail exchange record. So with the mail exchange record, it will identify what is the mail server, and then it will do the interpretation of this IP address. So this is a simple example of how we are using the DNS. So the next terminology that we need, there will be a lot of new terminology. So let us look into the next terminology. So the next terminology that we want to look at is namespace. So what do you mean by a namespace? A namespace is nothing but it maps each address to a unique name, and it can be organized in two ways. One is it can be organized as a flat or a hierarchical. So in a flat namespace, a name is assigned to an address. So our name in this space is a sequence of characters without any structure. But what is the disadvantage of this flat namespace? The disadvantage is that it cannot be used in a large system such as the internet, because it must be centrally controlled to avoid ambiguity and duplication. So we can just assign one name to an address. But since internet, we know there are day by day lot of systems are being added, and if you are giving a particular name, we cannot reuse it as the other name. So we need some central uh, authority to take care of that. So for that purpose, we are not going for flat namespace. So that is the main reason we are going for a hierarchical namespace. So each name is made of several parts. The first part can define the nature of the organization. The second part can define the name of the organization. The third part can define the departments in the organization and so on. So basically, in internet, we follow the hierarchical namespace. Now let us look at what is the domain namespace. So to have a hierarchical namespace, a domain namespace was designed. So in this design, the names are defined in an inverted tree structure with the root at the top. So we are having an inverted tree structure. A tree can have only 128 levels. So level 0 is basically called as your root. Likewise, we are having level 1, level 2 up till 127. So this is basically called as your domain name space. So here in this slide also we are having a diagrammatic representation of a domain namespace. So here we have various labels, or we have a single root. Under root we having n number of labels, like we have arpa.com, .edu, org, ad, z, w, etc. So we'll study one by one in the coming slides. So first we'll understand what you mean by a label. So each node in the tree has a label, which is a string with a maximum of 63 characters. The root label is a null string, or it is called as the empty string. So DNS requires that children of a node have different labels, which guarantees the unique of the domain names. What do you mean by domain name? So we have already seen. So each node in the tree has a domain name. A full domain is a sequence of labels that is separated by dots. The domain names are always read from the node up to the root. The last label is the label of the root. This means that a full domain name always ends in a null label, which means that the last character is a dot because the null string is nothing. So here they have shown you an example of domain names and labels. For example, let us check challenger.atc.fhda.edu. So we have various labels. So a challenger is one label, ATC is one label, FHDA is one label, EDU is one label. But the domain name is challenger. If you're navigating from this node, means this is the label challenger.atc. So next node means atc.fhda.edu. So if you are navigating from this node, means it is called as fhda.edu. This is a domain name. From edu, if you want to navigate, you can tell it as edu dot as the domain name. So it will be ending with the root, which is nothing but the null label. So once you understood that, now you should be able to identify what is a fully qualified domain name and what do you mean by a partially qualified domain name. So if a label is terminated by a null string, it is called as a fully qualified domain name. So the name must end with the null label, but because null means nothing, the label ends with the dot. For example, when you say it is a partially qualified, if it's not ending with a null string or a root, you call it as a partially qualified domain name. A PQDN starts from a node, but it does not reach the root. It is used when the name to be resolved belongs to the same site as the client. Here the resolver can supply the missing part, call this suffix to create an FQDN. Let us look at this example. So here they have shown you the difference between a fully qualified domain name and partially qualified domain name. So a fully qualified domain means, as I already told you, it has to end with a dot. So if you look at this, it has challenger.atc.fhda.edu www.funny.int. Like here we are having this always ends with the dot. Now let us look at partially qualified domain name. So partially qualified domain name will not be ending with the dot. So here if you see challenger.atc.fhda.edu, so it stops at the edu domain itself. It is not navigating till the root. So here also dot is missing, here also dot is missing. So this is basically called as your partially qualified domain name. Now let us see, for example, here they have shown you a diagram. So here we are having a .com.edu. So under .com we are having n number of subtrees with n number of labels. So we are having something called a zone. So we will see in the next slide, in the coming slides, what is a zone, etc. So here you can see this is one domain. This green color is one domain. This yellow region is again called as one domain. So likewise under edu also you can classify it into various domains. Zone and domains. So now let us see what you mean by a zone. Since the complete domain name hierarchy cannot be stored on a single server, it is divided among many servers. What a server is responsible for or is having authority over is called as a zone. We can define a zone as a contiguous part of the entire tree. See, if a server accepts responsibility for a domain and does not divide the domain into smaller domains, the domain and the zone refer to the same thing. A server makes a database called as a zone file and keeps all the information for every node under that domain. However, if a server divides its domain into subdomains and delegates part of its authority to other servers, then domain and zone might refer to different things. So from this slide, we can understand whichever server is responsible or which is having control over a particular area or a particular tree, we call it to be a zone. The distribution of namespace. The information contained in the domain namespace must be stored. So, however, it is very inefficient or also unreliable to have just one computer store such a huge amount of information. So, if you are going for a centralized storage, it is inefficient. So, that is what they are trying to say here. So DNS allows domains to be divided into smaller domains, which is called as your subdomain. So each server can be responsible or authoritative for either a large or a small domain. In other words, we have a hierarchy of servers in the same way that we have a hierarchy of names. So here we can see there is a root server. So under the root server we have some devices, and under this we are also having a number of devices. Server. A root server is a server whose zone consists of the whole tree. A root server usually delegates its authority to other servers, keeping references to those servers. So there are several root servers, each covering the whole domain namespace. The root servers are distributed all over the world. Now coming to the primary and secondary server. So DNS basically has two types of servers called as primary and a secondary. A primary server is the server that stores a file about the zone for which it is in authority. So it is responsible for creating, maintaining and updating the zone file. It stores the zone file on a local disk. So what do you mean by a secondary server? When you transfer the contents from the primary to a secondary server, the secondary server data will store as a backup. So a secondary server is the server that transfers the complete information about a zone from another server and stores the file on its local disk. It neither creates nor updates the zone files. If updating is required, it must be done by the primary server, which sends the updated version to the secondary. The primary and secondary servers are both authoritative for the zones they serve. A server can be a primary server for a specific zone and it could be a secondary server for another zone. Therefore, when we refer to a server as a primary or a secondary server, we should be careful about which zone we refer to. A primary server loads all the information from the disk file. The secondary server loads all the information from the primary server. When the secondary downloads information from the primary, you basically call that process to be called as a zone transfer. Now let us look at the DNS in the internet. So DNS is a protocol that can be used in different platforms. In the internet, the domain name space, that is the tree, is actually divided into three sections. So first is called as a generic domain, then we have country domain, and the last one is called as the inverse domain. Now let us look at what do you mean by generic domain. So this is the DNS in the internet. So we have seen already we have a root server. Under the root we have various servers. So you have inverse domain, generic domain and country domain. So what do you mean by generic domains? The generic domains define the registered host according to the generic behavior. Each node in the tree defines a domain which is an index to the domain namespace database. Looking at the tree, we see that the first level in the generic domain section allows 14 possible labels. So these labels describe the organization types. So all of you will be knowing that this is somewhat. So coming to the generic domain, so we have various types of URLs. So it could be aero, biz, com, cooperation, education, government, info, int, military, name, net, org, etc. So we have different types of email IDs, right? So these are some of the, not email IDs, the server addresses. So the generic domain labels, basically we have Aero. Aero stands for your airlines and aerospace companies. This stands for your business. Com means it's a commercial organization. Yahoo.com, Google.com means it's a commercial organization. Then cooperative means cooperative business organization. Education, it's an educational institution. Government, GOV. Info means information service provider. Int means international organization. Military or groups. Then we have museum, then name, then net, org. Org is your non-profit organization. Then we have pro. Pro means it's your professional individual organization. So these are some of the various labels that come under the generic domain. Now let us look at the next topic. It's called as your country domain. So from the term itself, you can understand that you have certain websites specifically for a particular country. The country domain section uses two character country abbreviations. US stands for United States. .in means India. So second labels can be organizational or they can be more specific national designations. The United States, for example, uses state abbreviations as a subdivision of US. Like for example, there is some DNS like ca.us. So the address uci.ca.us can be translated to the University of California, then Irvine in the state of California in the United States. So this is how this is the meaning of this ca.us. So looking at the country domain, so we have the root. So under the root, we can have various labels like AE, FR. FR means it's your France, then US, ZW. So likewise, we will be having the domain names, addresses. Now let us look at the inverse domain. So inverse domain is basically, it will, for example, IP addresses uses the in address.arpa domain. For example, if an IP address, now let us look at the address. So for example, there is an IP address like 192.168.10.255. In inverse domain, how do they read this address? For example, I'm saying. So we have to read it from the reverse direction. So it will be the first one will be 25.10.168.192 and then we have in addr.arpa. So reverse lookups basically use the pointer records. So as I spoke in the previous slide, so this is a diagrammatic representation of your inverse domain. So as I told you, there is a root level. So under root we are having ARPA. So under ARPA only we are having in ADDR. So under that only we can write the IP address. So the IP address is 132.34.45.121. So in the inverse domain, how do we read it? We have to read it from the bottom up. So the address that we are going to, the inverse domain address will be 121.45.34.132.in.addr.arpa and it will end with the dot. Okay, so this is how we will be reading it in the inverse domain. Now we are going to see resolution. So what do you mean by resolution? Mapping a name to an address or an address to a name is basically called as your name address resolution. So now in the resolution, there are two types of resolution. One is called as your recursive resolution. The other one is called as your iterative resolution. So let us see the working of recursive resolution. So recursive resolution, for example, a client wants to access some data from macro.com. So as we have seen in the root structure, so there is a root server at the top. Under the root we have n number of servers. So first the client, let us see this arrow. So the client is sending the request to fhda.edu. Since this is not the expected server, what it will do, it will be forwarding the request to the next server. It is going to the edu server, then it goes to the root server, then it goes to the .com server, then it goes to macro.com. So since this is the intended server, it will be sending some response. So it will again navigate from macro to com, then root server, edu, fhda, then finally the response. Once the request has been initiated, this client server will be getting the answer finally. So this is basically called as your recursive resolution. Now let us see what will happen in iterative resolution. So in iterative resolution, the same process. There is a client server. Finally, it wants to talk to macro.com. So first, the clients go and hit the client request will go and hit the fhda.edu server. So since this is not the intended recipient, so it will send back the address of the next server to contact. Then the client has to send the request to the next server. It will get the response. Likewise, the client will be keep on sending the request to the next servers, and finally when it hits the macro.com, it will be able to get the response. So this is basically the difference between the recursive and an iterative resolution. So recursive means once if you send the request, you have to sit and wait. Finally, you'll get the answer. But iterative resolution, that is not the case. So the client has to send to each and every server to get the response. So that is the difference between the two servers. Now let us look at the next topic, that is called as your caching. So caching is an important concept in your DNS. Generally, for example, if you want to access any website, so you just type the URL. So if the URL is already, say for example, google.com, I have already browsed google.com, means the Google's address will be already stored in my server. So automatically, immediately you will be getting the response. So in case if it is not stored in your server only, it will be fetching that address. So caching is one uh, important aspect of your DNS. So it will reduce the time. So that is the basic idea of this caching. So each time a server receives a query for a name that is not in its domain, it needs to search its database for a server IP address. So reduction of this search time would increase the efficiency. So DNS handles this with a mechanism called as caching. So when a server asks for a mapping from another server and receives the response, it stores this information in its cache memory before sending it to the client. If the same or another client asks for the same mapping, it can check its cache memory and resolve the problem. So caching basically speeds up the resolution, but it can also be problematic. So if a server caches a mapping for a long time, it may also send an outdated mapping to the client. So to counter this, they are using two types of techniques. So one is they are using a parameter called as TTL. So TTL is basically called as your time to load. Time to load means how long that data will be valid. So first, the authoritative server also adds information to the mapping called TTL. So it defines the time in seconds that the receiving server can cache the information. After that time, the mapping will be invalid and any query must be sent again to the authoritative server. And the next feature that they have added is called as your TTL counter. DNS requires that each server keep a TTL counter for each mapping it caches. The cache memory must be searched periodically and those mappings with an expired TTL must be purged. Okay. So the next important uh, topic that we are going to see is called as your resource records. So the zone information associated with the server is implemented as a set of resource records. So in other words, a name server stores a database of the resource records. A resource record is basically a 5-tuple structure. Basically, it is a domain name, then we have type, class, TTL and value. The domain name field is what identifies the resource record. Then we having the value field. The value defines the information kept about the domain name. Then the TTL will define how long it can be available in the network. And then we are having the type, it will define how the value should be interpreted. So resource records, as we have seen, there are basically 6 types of records. One is called as your A record. A record is nothing but it is a 32-bit IPv4 address. Then NS means it identifies the authoritative server for a zone. Then we are having CNAME. It defines an alias for the official name of the host. Then we are having SOA record. So it marks the beginning of a zone. Then we have MX record. So it is nothing but a mail server or a mail exchange. Then we are having 4A. So that is called as basically an IPv6 address. So I will show you a practical demo of how all these records will be there, what will be stored in your system. So likewise. Okay, but for the time being, you just try to remember the types of resource records. So then comes the DNS messages. So we know in a network, each and every protocol they'll be exchanging information by means of some messages. So now let us look at how the DNS messages frame format will be, what the DNS message will be looking like. So DNS has two types of messages. One is called as a query and response. So both types have the same format. The query message consists of a header and a question record. The response message consists of a header, then question records, answer records. It also has authoritative records and additional records. So this is the diagrammatic representation of your query and response message. So in a query message, we basically have a header, then followed with the question section. Then in the response message, we have the header followed by the question section. Then we are having answer, authoritative section, then addition section. So authoritative section is nothing but which server is responding. So those information will be specified in the authoritative section. So this is the message format. Now coming to the header format, the header format basically has totally 6 fields are there. First we are having the identification, then we are having the flags, then we are having number of question records, number of answer records, then number of authoritative records, and number of additional records. So this is the header that will be attached in a DNS messages. Then coming to the types of records, as we have seen, the question records are used in the question section of the query and the response message. The resource records are used in the answer, authoritative and additional information sections of the response messages. Now let us look at what are registrars. How are new domains added to the DNS? So this is done basically through a registrar. There is a commercial entity that is accredited by ICANN. So a registrar will first verify that the requested domain name is unique and then it enters in the DNS database. A fee will be charged for this. Now let us look at dynamic domain name system. It's basically called as your DDNS. So the DNS master file must be updated dynamically. So the dynamic domain name system therefore was devised to respond to this need. So in the DNS, when a binding between a name and an address is determined, the information is sent usually by the DHCP to a primary DNS server. So DHCP stands for your dynamic host configuration protocol. So the DHCP basically will be providing IP address in a network. The primary server updates the zone. The secondary servers are notified either actively or passively. Encapsulation. So DNS can either use TCP or UDP. So in both the cases, the well-known port number used by DNS is actually port number 53. So this protocol only uses uh, the services of TCP and UDP, but where it uses TCP and where it uses UDP, you need to understand. So UDP is used when the size of the response message is less than 512 bytes because most of the UDP packages have a 512 byte packet size limit. If the size of the response message is more than 512 bytes, then TCP will be used in this case. So DNS can use the services of TCP or UDP using the well-known port number 53. Next, we are going to see the demo of DNS. So I will basically show the demo using Wireshark first, and then I will also show you the demo using the CLI. Okay, using your command line prompt. So we have discussed about the resource records, right? So we'll be using the command prompt to check those commands. Now let us see the working of DNS using the Wireshark tool. Wireshark is a packet capture tool that will be basically capturing the packets that are going in and out of my NIC card. So let us go to the Wireshark. So I have already opened the Wireshark tool and you will be able to see the tool like this. So you have to go to capture and just give the option. I am capturing in a Wi-Fi network, so I have just choose Wi-Fi. In case if you are using Bluetooth or LAN connection, you have to just go and choose the options. So I am connected to Wi-Fi. I have selected this. In case if you are having a local area network Wi-Fi, you can Bluetooth. You can go and just choose which you want. So since I am connected to Wi-Fi, I am just giving a start. Okay, so then I want to open this tool. So I have used the website called testasp.vulnerabilitywebsite.com. So here you have to just go and log in. So I've already created the account. So just I am logging in using the test. Okay, so this is actually a test website to introduce SQL injection. So we are not interested in that. So after doing the packet capture, you can just go and stop. So you'll be able to see it is capturing the packets that are going in and out of the network. Basically, you can see all the packets that are going. So you have various protocols like TCP, UDP, DNS, ICMP, quick protocol likewise. So if you look at the packet capture, so here you can see there is a DNS packet. So that is a query asking for a solution test asp.vulnerability.com. So here if you can see, so as we have already studied, DNS uses a port number called 53. So from my PC, I am connecting to the DNS server which is located at port number 53. So here in DNS, you can see there is a transaction ID, you can see the flag field, then there is a question, then answer RR, authority RR, and additional RR. So RR is nothing but your records. Okay, so here it is asking that type is an HTTPS, class is an in record. Okay, so this is a query that is being sent from my system. Okay, so let us look at the response. So this is the response that we are getting from the other side. So here you can see if from the server, so that is the source port. So source port is for 53 and it is being sent to the destination port is nothing but my PC. So 53,441. So now let us look at the response. So you have a transaction ID, flags, then we have a question, authoritative server. So this is the authority RR means it's the authoritative server. So let us look at the authoritative node server. So here you can see it is telling it is a type is SOA, class is in, and the name. So this is what your DNS message will look like. Okay. And finally, this DNS message will be mapped to this particular address. So here you can see it has found out the address of the server. So once it has found out the server, then it will be connected to that page. So after that, we will be able to send the username password. It will accept it. So this is how you have to uh, have to identify the DNS. So like this, we can see TCP packets, etc. So since that is not our area, I am just not going in depth to that. I hope you understood the working of the DNS. So in the next video, I will show you how to check this DNS mapping or this DNS commands in your system using the command line prompt. Okay, thank you for watching.